2.2 says if this equation exists, which we have sigma of applying the rule 1 over 3p plus 1 over 6 is equal to 20 and 1/6. Determine the value of k, which is the upper limit of this sigma notation. So I've rewritten the question here, and basically what this is saying is that find the value of k such that if we evaluate the sigma notation, we will find a total sum of 20 and 1/6. So first step, in order to solve any question involving sigma notation, is we need to expand if we can. So since we know p is equals to 0, we can substitute into p and get the first term. So if p is 0, then our first term is just 1 over 6 plus, if p is 1, it will be 1 over 3 plus 1 over 6, which is 3 over 6 plus, if that is 2, then it's 2 over 3 plus 1 over 6. But since we have p as a variable and not as a power, we already know that this will be a problem of arithmetics. So here this is a linear problem and we'll need to find the difference from this. So how do we get from 1 over 6 to 3 over 6? That will be the difference. So d will be equal to 3 over 6 minus 1 over 6, which is 2 over 6, which simplifies to 1 over 3. So your difference is 1 over 3. Your a value is 1 over 6. That means you can use the sum of formula. But be careful, because when we're using the sum of formula, Sn is equals to n over 2, 2a plus n minus 1d. In this case, n is not equal to k. So if we solve for how many numbers we need to get the total of, in this case, it's 20 and 1 over 6, or yeah, since it's a mixed fraction, it would be 121 over 6 if we rewrote it. So we already know that the sum of the sigma is gonna result in this total, but we are looking for the value of k, and k is just an upper bound. P is the lower bound. N that we use in this formula represents the number of numbers. So if we're to write the relationship between the numbers we're actually adding, which is n, and say n is equals to the top number k minus the bottom number, which is 0, or p in this case, plus 1. And this plus 1 is really important. So this just shows us the relationship. So we know now from this that k will be, since p is 0, k plus 1, meaning k will be equal to n minus 1. We could make that substitution now, or make this substitution now, but it could make things a bit complicated. So we tend not to, only do it at the end. But even if you do it now, if you can handle it, then it's cool. So we continue with this problem, making the respective substitutions. A would be 1 over 6 plus n minus 1. D will be 1 over 3. And then we can simplify this. On the inside, outside we still have 1 to 1. If we multiply by 2 everywhere, we can remove this 2. So multiplying this by 2 would cancel. Since this is 6, it's actually 3 times 2. You cancel this 2, leaving us with 1 to 1 over 3 is equal to n. And what's going on inside here is 2 multiplied by 1 over 6 is 2 over 6, which is 1 over 3, plus 1 over 3n minus 1 over 3. Then, of course, 1 over 3 and 1 over 3 cancel, and we're left with 1 to 1 over 3 is equal to n squared over 3. And then here we can just multiply out the 3 To get n squared is equals to 1 to 1. Take the square root of both sides. You get n is equals to 11. And then remember, what we're looking for is not n, or n is not equal to k, but they are related through this relationship. This means that k is equals to 11 minus 1, and k will be equal to 10. So that's how you can solve that problem.